Every week, a new AI model drops, and every single one comes with a press release showing charts where their model beats everything else on benchmarks. GPT-4 state of the art. Claude 3 beats GPT-4 on reasoning. Gemini outperforms both. Llama 3 competitive with frontier models. New Chinese model, #1 on MMLU. The problem? Half these claims are misleading. Some are outright gaming. The benchmarks themselves are broken. And as a result, choosing the right AI tool for your actual needs has become harder than it should be. Let me walk you through the benchmark problem, what's actually happening, and how to cut through the noise. An AI benchmark is a standardized test designed to measure some aspect of model capability. The idea is similar to a standardized exam for students, a common yardstick that allows comparison across models trained by different labs with different approaches. Benchmarks cover a wide range of capabilities. Reasoning, can the model solve logical problems? Knowledge, does it know facts across domains? Math, can it do calculations and proofs? Coding, can it write and debug software? Language understanding, summarization, and many more. The most commonly cited benchmarks include MLU, Massive Multitask Language Understanding, a knowledge test across 57 academic subjects, Human Eval, Coding, GSM-8K, Grade School Math, Math Harder Math, HelloSwag, Common Sense Reasoning, and newer ones like GPQA, Graduate Level Scientific Questions, and MMMU, Multimodal Understanding. These benchmarks are genuinely useful for researchers comparing models under controlled conditions and tracking progress across years. The problem arises when companies use them for marketing purposes, and when the relationship between benchmark performance and real-world usefulness breaks down. The most fundamental problem with AI benchmarks is data contamination. AI models are trained on enormous amounts of internet text. Benchmark datasets, the questions and answers used to evaluate models, are also on the internet. They're on papers, on GitHub, on discussion forums, in textbooks. If a model's training data includes the actual questions and answers from a benchmark, it can memorize the test rather than actually learning the underlying capability the benchmark is supposed to measure. This is like students who memorize the specific answers to past exam questions rather than learning the subject. They'll score high on that test. They may not actually know the material. This is a serious and widespread problem. Some labs are more rigorous than others about filtering benchmark data from training sets, but it's impossible to completely prevent and difficult to detect. A model that dramatically outperforms expectations on a benchmark should always raise questions about whether it's been trained on that benchmark. A related issue is benchmark saturation and deliberate gaming. As benchmarks become widely used, labs inevitably optimize their training processes specifically to improve scores on those benchmarks. This is known as Goodhart's law in machine learning. When a measure becomes a target, it ceases to be a good measure. The model gets better at the benchmark specifically, which may not reflect genuine improvement in underlying capability. Some of this is innocent. If reasoning benchmarks reward certain styles of step-by-step thinking, labs will train models to think in step-by-step ways, which actually does improve reasoning generally. But some of it is less innocent. Selective reporting, showing only the benchmarks where your model performs best, benchmark-specific fine-tuning, cherry-picked evaluation settings. The model card for a major new release might show results on 15 benchmarks and be best in class on 8 of them. What they won't tell you is that they ran evaluations on 30 benchmarks and only included the ones that looked good. Even honest, uncontaminated benchmark results miss crucial dimensions, ions of real-world model quality. Instruction following. Does the model actually do what you ask? Does it maintain constraints throughout a long response? Does it remember that you said no bullet points 3 messages ago? Benchmarks rarely capture this. Consistency and reliability. Does the model give consistent answers when asked the same question differently? Benchmark scores are averages that hide significant variability. Hallucination rate. How often does the model confidently state things that are false? This is one of the most practically important dimensions of model quality, and it's difficult to measure with standardized benchmarks. Calibration. Does the model know what it doesn't know? Does it express appropriate uncertainty? A well-calibrated model is far more useful in practice than one that's always confident. Long context quality. Can the model effectively use information from a very long document, or does its attention degrade partway through? Lost in the middle behavior. Forgetting context from the middle of a long document is a real and important failure mode. Conversational coherence. For multi-turn conversations, can the model maintain consistent, coherent dialogue? Benchmarks typically evaluate single-turn interactions. Refusal behavior. Does the model refuse to help with legitimate requests because they superficially resemble something it was trained to avoid? Overly cautious models that refuse normal requests are less useful, but this isn't reflected in standard capability benchmarks. The AI research community has recognized these problems and developed better approaches. Chatbot Arena, LMSES. This platform collects blind preference judgments from real users. You interact with two anonymous models simultaneously, and after the conversation, you vote on which was better. The model identities are revealed only after voting. This crowdsourced, preference-based ranking avoids many of the contamination and gaming issues with benchmark tests and reflects actual human preferences. The Chatbot Arena ELO rankings have become one of the most trusted signals in the field. Needle in a haystack tests. A practical evaluation for long context capability. You hide a specific piece of information inside a very long document and ask the model to find it. This tests whether long context windows actually work in practice. Red teaming evaluations. Having human experts try to make the model produce bad outputs, fail at reasoning, or behave inconsistently. More indicative of real-world robustness than clean benchmark conditions. Domain-specific expert evaluations. For specialized applications, having domain experts evaluate model outputs in their field. A model that scores high on generic MMLU may perform very differently on specialized medical, legal, or scientific questions. Your own task evaluation, the most underrated approach. Just test models on the specific tasks you actually need them for. Create a small evaluation set representative of your real use case and run all the models you're considering. This will tell you more than any published benchmark. Given all this, how should you actually evaluate AI models for your needs? Start with the Chatbot Arena leaderboard as a starting signal. It's not perfect, but it represents aggregated human preference at scale and is harder to game than benchmarks. Identify your key use cases. Are you primarily writing, coding, analysis, research, customer service, creative work? Different models have genuine strengths in different areas. Run your own evaluation. Take 10 to 20 real examples of the work you need to do, run them through the models you're considering, and evaluate the outputs yourself or with your team. This is 5 hours of work that will save you from a wrong decision. Test adversarially. Give models your hardest, most ambiguous, most nuanced tasks, not the easy ones. How do they perform when it's genuinely difficult? Evaluate refusals. If you need the Dell to help with tasks that might be edge cases for safety guardrails, test this explicitly. Some models refuse too much and become practically useless for legitimate purposes. Consider cost and speed. The most capable model isn't always the right choice. If your use case is high volume and the tasks are within the capability of a smaller model, the cost and speed difference between frontier models and more efficient options can be enormous. Reevaluate periodically. The landscape is changing so fast that the best model for your use case 6 months ago may not be the best today. AI benchmark wars are largely a marketing exercise designed to create the impression of superiority rather than reliably measure it. The sophisticated approach is to look past the press release benchmarks, use better evaluation signals like Chatbot Arena, and most importantly, test models on your actual use cases. The model that's genuinely best for you is the one that does your specific work best, not the one with the most impressive chart in a launch announcement. Subscribe for weekly coverage of the AI industry without the spin. I try to give you the analytical framework, not just the headlines. See you next week.